Hello everyone, welcome to the Engineering Geology and Hydrogeology course. Last lesson, we studied magmatic rocks, one of the three major rock types. Today, let's learn about sedimentary rocks among the three major rock types. Sedimentary rocks are formed at or near the Earth's surface under normal temperature and pressure conditions through the processes of transportation, deposition, compaction, and cementation of loose clastic materials. Magmatic rocks originate from the interior of the Earth, is the result of dynamic forces within the Earth, while sedimentary rocks originate from the Earth's surface, is the result of extraterrestrial dynamic geological processes. Sedimentary rocks make up 75% of the land area, 5% of the volume of the Earth's crust. Its thickness is generally several hundred meters. In some areas, can be thousands or even tens of thousands of meters. Various engineering structures, such as roads, bridges, dams, and mines, are almost exclusively founded on sedimentary rock formations. How are sedimentary rocks formed? Let's learn the origin of sedimentary rocks. Sedimentary rocks are formed from source materials, including magmatic rocks, older sedimentary rocks, and metamorphic rocks, through weathering processes, as introduced in the preliminary section, such as mechanical disintegration, chemical dissolution, and biophysical weathering, which break them down into clasts. These clasts are then transported by water, gravity, wind, or glaciers to depositional environments like ocean basins, lake basins, riverbanks, estuaries, or enclosed depressions. Finally, through diagenesis, including compaction, dehydration, and cementation, sedimentary rocks are formed. It's a long process. It often takes hundreds of thousands of years, millions of years. Compared to this process, the iron sharpened to a needle and the foolish old man who removed the mountains pale in significance. In the process of learning and growth, everyone should cultivate the sedimentary spirit of sedimentary rocks, patience, accumulation, and gradual progress. Sedimentary rocks are products of weathering, formed by a series of diagenesis. What are the chemical compositions of sedimentary rocks? Sedimentary rocks are basically the product of magmatic rock weathering. Therefore, its chemical compositions are very close to that of magmatic rocks. But due to different causes, there is a slight difference. Its composition includes clastic material, clay minerals, chemical sediments, organic matter, and biogenic debris, as well as cement. Clastic debris forms clastic rocks. Clay minerals constitute clay rocks. Chemical precipitates form chemical rocks. And organic matter with biological remains generate biogenic rocks, while cement fills the intergranular pores and acts as a binding agent. Among them, plastic material refers to fragmented particles derived from the weathering and disintegration of parent rock containing mineral debris, rock fragments, and pyroclastic debris. The mineral debris is mainly composed of quartz, feldspar, and white mica. The rock fragments originate from magmatic rocks and older sedimentary and metamorphic rocks. Pyroclastic debris originates from volcanic breccia and ash. Clastic rocks have strong graininess. The picture shows pyroclastic rocks. It can be clearly seen that rocks are composed of aggregates of debris. Clay minerals. Clay minerals are secondary minerals formed by the chemical weathering and decomposition of primary minerals represented by kaolinite, mormorillonite, hydromica, and the like. Such minerals have a strong pi, hydrophilic plasticity, and swellability. Chemical deposits. Chemical sediments refer to minerals precipitated from true solutions or colloidal solutions, or formed through biochemical deposition processes. Common chemical deposits include calcite, dolomite, gypsum, rock salt, iron oxide, and manganese oxide. Organic matter and biogenic debris. Organic matter and biological debris are minerals formed through the organic chemical alteration of biological remains. The photo shows fossilized shells, coral reefs, and diatomaceous earth remnants in the rock. What we introduced before are granular matters that makes up sedimentary rocks. Such substances have the characteristics of being loose, so a medium is needed to hold them together. The cement refers to the mineral material that fills the interstitial spaces between sedimentary particles and binds them into a coherent mass. Then the cement refers to the mineral material that fills the pores between sedimentary particles and binds them into a coherent mass. Common cements include siliceous cementation. Silica cementation is light in color and high in strength. Ferrous cementation. The iron cementation is reddish-brown nacre with higher strength. Calcareous cement is light in color with low strength, brittleness, and high susceptibility to dissolution. Argillaceous cementation. Mud cementation structure is loose with lowest intensity, softening with water. Carbonaceous in volcanic tufaceous cementation. This kind of cementation has low density and is easy to weather. Since sedimentary rocks are made up of loose particles formed by compression and cementation, cement has great influence on the engineering properties of rock. The engineering properties of sedimentary rocks with siliceous and ferruginous cements are generally favorable, while rocks formed by calcareous, argillaceous, carbonaceous, and volcanic tufaceous cementations have poor engineering properties. In this lesson, we mainly studied the genesis of sedimentary rock, chemical composition, and material composition. Next class, we will continue studying the sedimentary rock textures, structures, and common types of sedimentary rock. See you in the next lesson.